At Galbraith High School, the lockers are arranged in banks of 20. Each bank of lockers consists of 6 columns of lockers. The first 2 columns in each bank consists of 2 larger lockers, and the last 4 are 4 smaller lockers. The lockers are numbered consecutively, starting at 1, moving down each column, and then to the next column, and so on. The first 21 lockers and their locker numbers are shown in the diagram. What is the sum of the locker numbers of the column of the lockers that contain the number 24? If you continue this, this would be 22, and this would be a large one called 23, and this would be a large one labeled 24. So the column that has 24, which is this one, the sum would be 23 plus 24, which is 47. B, the sum of the locker numbers for the one column is 23. What are the locker numbers in this column? Okay, so a column can have either 2 lockers like this guy, or it can have 4. So we're either talking about 2 consecutive numbers that add up to 123 or 4 consecutive numbers that add up to 123. Let's try 2 first. So my 2 consecutive numbers are x and x plus 1. And that's equal to 123. And let's see what happens here. This is going to be 2x is equal to 122. So therefore x is 61. So I think 61 and 62 would be, would work. And that would give me a column with locker numbers that add up to 123. The sum of the locker numbers for another column is 538. What are the locker numbers? Okay, so same kind of story here. Either it's 2 or 3. So let's try 2 first. 538. When you do this, you actually get x equal to 268.5. So obviously that doesn't work because the number has to be a whole number. Okay, so that means it's probably 4 consecutive lockers, like something like this. 4 consecutive numbers is what I meant to say. So x plus 1 plus x plus 2 and plus x plus 3, like that. And that's got to be 538. And when you do that algebra, you will get x equal to 133. So that means those locker numbers were 133, 134, 135, and 136. Explain why 2013 cannot be the sum of any locker numbers. So the same kind of story. Either we have 2 consecutive numbers that add up to 213, or we have 4 consecutive numbers that add up to the 213 that they are telling us is the sum. Okay, so let's do the first one. When you do the first one, this becomes x equals 1006. Okay, well, that seems like a good a result, but that would mean that the 2 numbers are 1006 and 1007. Okay, now why is that not a good solution? Well, this requires a little bit of thinking here. The way this is working, and you have to do a little bit of extrapolation, ... to get this, is that the first 4, if you notice, is 1, 2, 3, 4, right? And then the next time you get those 4 big ones, again, the units digits are 1, 2, 3, 4. And that's how it kind of goes on. So if you extrapolate to 1000, it becomes 1001, 1002, 1003, and 1004. That's basically extrapolated all the way to 1000. So if you keep going like that, the next column would actually be a column with 4 lockers, and those numbers would be 1005, 1006, 1007, and 1008. So even though we did get a whole number, it would not match. You'd either have that scenario or something like that. So this is not possible because you would have a column with 4 lockers once you get into that 1006 number. Now this one here, when you solve that, you get 501.75, and that obviously is not a whole number, so that doesn't work either. So that's why 2013 cannot be the sum of any columns of locker numbers. Expand and simplify the expression. Okay, shouldn't be a problem. So if I got a minus 1 times 6a squared minus a minus 1. So if I do the expansion, it'll be 6a to the power of 3 minus a squared minus a minus 6a squared plus a plus 1. And then collecting like terms, it'll be 6a to the power of 3 minus 7a squared plus 1, because the a is canceled. Okay, so that's all that they're asking. Determine all values of theta for which 6 cos theta cubed minus 7 theta squared plus 1 is 0, and theta is between minus 180 and 180. Round each answer to one decimal place where appropriate. So this obviously looks very similar to this, and if you let cos theta equal a, it becomes identical to that. So that's what I'm going to do. And since it was the expansion of that, we've already got it factored. So it's basically this. And that was 6a3 minus 7a2 plus 1. And of course, this is the original with a equal to theta, which is the substitution I made to make it look exactly like part A of the question. Okay, so that basically means that either a is 1, and this guy here, I don't think I can factor that. I'm unfortunately going to have to use a quadratic. That's okay. A is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So when you do this, you get 1 plus or minus, let's see here, 1 plus 24 is 25. So that's going to be 1 plus or minus 5 over 12. And that's 6 over 12, which is a half, or minus 4 over 12, which is minus 1/3. So these are my solutions. But we have to figure out the value of theta, and not the value of cos theta, which is what a represents. Okay, so let's do this. If a is 1, that means cos theta is 1. And what are the other ones? A half. Cos theta is either also a half or negative 1/3. Those are the solutions, right? Yeah. So then in this range, only in that range, theta would be either 0, 60, minus 60 degrees, 109.5, or minus 109.5. And those values you can easily get on a calculator. You're allowed to use a calculator on the Canadian exams. And I always try to, draw the graph. It won't give me the exact value, but it'll give me some sort of an idea between that range. So this is my range, right? 180 to minus 180 to 180. So if this is sort of the theta and cos theta, then when it's 0, obviously you got this guy. Sorry, when cos theta is 1, then theta is 0, so that takes care of this guy. And then half is sort of somewhere, let's see here, cos theta is a half, so this guy, and that's corresponding to 60. And then minus 1/3 is down here somewhere. So it's somewhere minus 1/3. Let me think about this. Yeah, it would be down there. So whatever that corresponds to. And I think my other one would be here somewhere. And I think the range, is here. I think I made the range a little too wide there. So those are the 4 values. Actually 5. 1, 2, 3, 4, 5, like that. And that's what we have. 1, 2, 3, 4, 5. So a little bit of a graph can also help you. And moving right along to part C. Determine all values of theta for which 6 cos theta cubed minus 7 cos theta squared plus 1 is less than 0 for theta between minus 180 and 180. All right, so same kind of story here. Since we've already worked with this, I think I can already factor it. It was 1, right? The roots were 1, a half, if I remember, from part B, and minus 1/3, if I remember. So I can immediately factor it. cos theta plus 1/3 because the root is minus 1/3. And we want that to be less than 0. Ah, okay, I got it. So we're going to have several kind of situations, right? Okay, so I've got to figure out what situations. So, well, the first thing I noticed actually is cos of theta. If we just look at cos of theta, that is always between 1 and -1, right? If I remember correctly. So cos of theta minus 1 would be, if I just write it here, cos of theta minus 1, if we subtract 1 from both sides, 0 and -2. So that means that cos of theta minus 1 is always less than 0. So it can never be greater than 0, because there are several scenarios to make this less than 0. The first is a negative for this guy, positive, positive, like that, right? And the other one would be negative for this guy, positive, positive, or negative for this guy, positive, positive, or all three negative. Yeah, I think that is how you do it. But here's the thing. We just talked about how this is always going to be negative, less than 0. So this scenario and this scenario are not possible. So we just omit those and we just concentrate on this guy and this guy. So hopefully that made sense. And therefore, let's do that. So we got cos of theta minus 1, I should say. And then we have cos of theta minus 1/2. And then we have cos of theta plus 1/3. And then the product, it has to be less than 0. So that way we got plus, plus, and negative as a possibility, or negative, negative, negative as the other possibility. And I think those are the only two. So let's explore those and let's see what we get. Okay, so if this is the case, let's see here. I think I should be okay for space. Okay, so the first scenario, negative, positive, positive. So that means the cos of theta, therefore, the cos of theta is, if it's negative here, that means the cos of theta minus 1 is less than 0. So cos of theta is less than 1, but it's always less than 1, so that doesn't really help us in any way. So I guess we just look at the other parameter, which is that it's greater than -1. Yeah, okay, so it's greater than or equal to -1. The other, like that, boundary. But this guy here, though, that's going to give me cos of theta. If it's above 0, that means it's cos of theta plus 1/3 is greater than 0. So that means cos of theta is greater than -1/3. Greater than? Let's see here. Yeah, -1/3. So let me squeeze that in here. Cos of theta is greater than -1/3. And similarly, this guy would give me cos of theta if it's greater than 1/2. Yeah. Yeah. And then I've got to combine all these three. Okay, I got it. So let me see if I can combine them. Let's see here. What's the lowest boundary I can go to on the upper limit? 1, I think. Yeah, and then the lowest, and then the other boundary would be 1/2. So combining, actually, I'm going to get 1/2 less than cos theta less than 1. Okay, good. Got it. And then that's cos theta, and then of course I got to figure out theta. So, and that is in this range right here between 180 and 180. minus 180 and plus 180. So in that range, I believe theta would be less than minus 109. Or sorry, not 109. We're doing this guy right here. So it would be either between 0 and minus 60, or it would be between 0 and 60. So that takes care of this guy. Okay, in a very similar way, we're going to tackle the next one, the three negatives. And when you do that big long song and dance, you're going to get, let's see here, cos theta is, again, less than 1. Okay, this one's going to give me cos theta is less than a half, and this one is cos theta is less than negative 1/3. So let's see here. That means if I combine those, cos theta is going to be greater than negative 1 and less than negative 1/3. That is the boundaries. And similarly, when I figure out the theta this time is going to be greater than minus 180, and then on the other end it'll be minus 109.5 to be exact, and then on the other spectrum it'll be plus 109.5 is the boundary of theta, and 180. So there you go. That pretty much concludes that question. If m and n are positive integers, an mn sequence is defined to be an infinite sequence x1, x2, x3, dot, dot, dot of a's and b's such that xi is a for some positive integer a, then xi plus m equals b, and if xi is b for some positive integer I, then xi plus n is equal to a. For example, AB, AB, AB is a 1-1 sequence. Determine all 2-2 sequences. Okay, so let's talk about this. Let's try to figure this out. So x1 is a. Okay? So x1 plus 2 would be b, which is basically x3. Now I say, well, where does all this come from? Well, it comes directly from the definition right here. I've let I equal to 1, and that's where I got this guy. x1 is equal to a. And then xi plus m, which would be 1 plus 2, and the 2 comes from this guy, which is where what they have given us, that it's 2. And that's where I got this. And now x1 1 plus 2 is x3, and that's b, which is right here. Okay, now let's keep going. And then the next one, let's do I equals 2. So maybe I should just put that in here. This was I equals 1, and now I equals 2. If I equals 2, then we'll use this one definition. That means x2 is equal to b. And then that definition would give me x2 plus n. This is n, and n is 2 in this case. So 2 plus 2, which is x4 is equal to a, according to this guy. So hopefully not too confusing. And that allows me to figure out the first 4. So x1, x2, x3, and x4. And then you can keep going like this. So to figure out x5, that would be I equals 3. So that would be 3, x3 plus 2, using the definition, where that's x5. And since x3 was b over here, x3 plus 2 by definition would be a. So we're just simply following what instructions they gave us in the question stem. That's all I'm doing. Might take a little bit of understanding, but that's pretty much all there is. And then similarly, for if I is 4, we'd have x4 plus 2, which is x6. And since x4 was a, this guy is going to be b. And so on. x5, if I equals 5, x5 plus 2, which is x7, x5 was what, A, so x7 would be B. And then when you put these together, it would be, let's see here, A for x1, x2 is B, x3 is, where's x3? X3 is B, x4 is A, x5 is A, x6 is B, x7 is B, and my guess is that it just kind of repeats like that. So that is one of the sequences. That's not the only one though, because notice they say determine all, so that makes me think that there's more, and there are more. And if you follow the same pattern, well, basically what you would do is to figure the next one out, you would then go back and start with I equals 1, but instead of letting it equal to A, you let it equal to B. And if you do that, you would get a slightly different string, I guess, or sequence is what I'm saying. Or you can, very interestingly, go back and sort of do this one again, but instead of doing it the exact same way where x1 is A, and then therefore x1 plus 2, which is x3, is B. That's fine, but then when you get to here, you do the same thing, but instead of choosing x2 to be B, choose x2 to be A, because that is allowed under the rules. You're just repeating this one. You don't necessarily have to do that. X1 equals B. You can just repeat this guy all over again. And when you repeat that guy, you actually get a slightly different sequence. Here you get x2 plus 2, which is x4, equal to B. And then when you keep figuring out values of x1, x2, x3, so forth, it would make a string of AA, BB, AA, like that. So here's one, well, dot, dot, dot is what I should have been including. And here's the second one. And similarly, I think I touched on it briefly there. If you let the first one, x1 equal B, and x2 equal A, you'll get a B, A, B, B, A, B, that kind of thing. And then if you let x1 equal B and x2 equal B, you will get a BB, AA, BB, AA type of string sequence. So those are the four, and that's what they're getting at with part A. Show that there are no 1-2 sequences. Well, we're going to follow the same definition for a 1-2 sequence, exactly what we did before. So let's go. If I equals 1, we have x1, and let's start with A. And therefore x1 plus 1, which is x2, let's have it equal B. And we'll try other scenarios, but let's see what happens here. Okay, if you keep going here, x2 plus 2 would be, which is x4, you would have to put A. And then you kind of keep going from there. But there's no x3 so far. You say, well, what happened? There's no x3. How do I get x3? Because remember, it's a 1-2 sequence. So when you go back and look at the definition, it's going to be hard or not possible. So we have to set it equal to something. So let's see if I equals 3. I'll let it equal something. Let me equal B. And therefore, when I do the 3 plus 2, which is x5, that's got to be equal to A, right? But the problem is, if I keep going with this definition up here, x4 plus 1, which is x5, that's got to equal B. So here I've got it equal to A, here I've got it equal to B. So this falls apart. This becomes a contradiction. So you say, okay, well, that didn't work. All right, no problem. Maybe I can get it to work in some other way, right? Because remember, there's more than one way of doing this. We started with x1 equal to a, let's start with x1 equal to b and see what happens. Therefore, x1 plus 2, which is x3, has to be equal to a. And if I keep going here, x3 plus 1, which is x4, that has to be equal to b. Now we have no x2, so we have to create an x2. Let x2 equal, say, b, or sorry, let it equal a. And therefore, x2 plus 1, which is x3, would equal b. But I already got x3 to equal a, and then I got x3 equal to b, so that's a contradiction. Now, they say, okay, well, instead of letting x2 equal a, how about if you tried b? Let's see what happens. Okay, if x2 equals b, then x2 plus 2, which is x4, would have to equal a. But I already got x4 to equal b, so again I have a contradiction. So the point is, no matter which direction you go and which letters you choose in whatever order, you'll always get contradictions, and therefore there are no 1-2 sequences possible.